Today we're looking at Lesson 4, Equivalent Ratios. In this lesson we're going to look more at equivalent ratios in real life situations. Let's start by looking at example 1 and reading the situation. The morning announcement said that 2 out of every 7 sixth graders in this school have an overdue library book. Jasmine said that would mean 24 of us have overdue books. Grace argued, no way, that's way too high. How can you determine who is right? Well, to start to determine who is right, let's start by looking for what ratio do we already know. What is our starting ratio? Well, the announcement said that 2 out of every 7 sixth graders in this school has an overdue library book. So our ratio to start would be 2 to 7. That is the ratio that we know is correct. So now we need to compare it to the ratio, or the part of the ratio that Jasmine gave us to see if that makes sense. Jasmine gave us 24 students had overdue library books. Since the 24 is students who have overdue library books, we got to figure out which number does that match up with or correspond with in the first ratio. Well, it says 2 out of every 7 students have overdue library books. So 2 is the number of students with overdue library books. So 2 and 24 are the numbers that correspond. So figure out how many total students there are. We need to figure out what number corresponds with 7. And then we can see if Jasmine's answer makes sense. So, how are we going to do that? Well, if we remember from last lesson, to make an equivalent ratio, we need to multiply both numbers by the same thing. So we can see what did we multiply by 2 to get to 24? Well, to multiply by 2 to get 24, we multiply by 12. If we multiply by 12 on one side of our ratio, to get an equivalent ratio, we need to multiply by 12 on the other. So I'm going to multiply by 12, and 7 times 12 is 84. So our new ratio is 24 to 84. That's equivalent to 2 to 7 because we multiplied by the same number to both sides. Now to determine who is right, we got to decide. Does that make sense? Well, can a class have 84 kids? That depends. If it's just a single class in which you're sitting in a classroom with, then that maybe doesn't make sense. But if she's talking about the whole 6th grade, then it does make sense. It could be a small school with 84 students in the 6th grade. So we would need more information to see who is right. Next, let's look at exercise 1. Decide whether or not each of the following pairs of ratios is equivalent. If the ratios are not equivalent, find a ratio that is equivalent to the first ratio. If the ratios are equivalent, identify the positive number C that could be used to multiply each number of the first ratio in order to get the number of the second ratio. So let's look at A. We have 6 to 11 and 42 to 88. It's time to decide, is that equivalent? Well, to make equivalent ratios, you multiply the one number of the first one by the same number on the second one. So you multiply 6 by a number to get 42 and 11 by a number to get 88. If they're the same number, it's equivalent. If they're not, then it's not equivalent. So to get from 6 to 42, what do we multiply by? Well, 6 times 7 is 42. To get from 11 to 88, what do we multiply by? Well, you multiply by 8. So in the first set of numbers, we multiply by 7. In the second set of numbers, we multiply by 8. Is that an equivalent ratio? No, it is not an equivalent ratio because it's not the same number. Well, what would an equivalent ratio be? Well, we just have to multiply by the same number. Let's use 7. We already multiplied by 7 on the first one, so 6 times 7 would be 42, so that would be our first number in our ratio. Now for the second number, you'll need to multiply by 7 again instead of 8. So 11 times 7 is 77. So you would get 42 to 77. It was not equivalent because we did not multiply by the same number. Let's look at letter B. 0 to 5 and 0 to 20. Well, what number did we multiply to get from 0 to 0? Well, to multiply by 0, you can really multiply by any number. So it could have been any number. So let's look at the second one to see what that one would be. From 5 to 20, you multiplied by 4. Could I multiply by 4 to get from 0 to 0? 0 times 4 is 0. So we could have multiplied by the same number. So yes, our ratio is equivalent. Why? Because we multiplied both numbers by 4. So our constant, or C, would be multiplying by 4. Okay, let's look at our last exercise in this lesson. In a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. Determine the amount of walnuts that are in the bag if there are 54 cashews. Use a tape diagram to support your work. Justify your answer by showing that the new ratio you created of the number of walnuts and the number of cashews is equivalent to 5 to 6. Well, to start, we start with our original ratio of 5 to 6. Now it says to use a tape diagram to justify it, so let's use a tape diagram. Remember our tape diagram? We're going to draw 5 boxes for the first number to show that part of the ratio. 1, 2, 3, 4, 5. And then 6 boxes for the second one. 1, 2, 3, 4, 5, 6. So we have 5 and 6. Now, we know that we need to get 54 cashews. Which number does that match up with, the 5 or the 6? Well, our original ratio was walnuts to cashews, meaning that the first number was walnuts and our second number was cashews. So the 54 would be by the second part of the tape diagram, or the second tape. Now, how did we get from 6 to 54? Well, we multiplied by 9. So that means 9 would go in each and every box. So we went 6 times 9 to get to 54. Well, we want an equivalent ratio, we need to do the same to the top. Multiply by the same number. So we're going to multiply by 9 again. Or put 9 in all of our boxes. So 9 times 5 is 45. So we would have 45 walnuts in the bag. Now it says, justify your answer by showing the new ratio it created is equivalent to the old ratio. Well, our new ratio is 45 to 54. Our old ratio was 5 to 6. To justify or show that they are equivalent, we need to show that they multiply by the same number from the old ratio to the new ratio. So to get from 5 to 45, we multiply by 9. Well, we also multiply by 9 from 6 to 54. So therefore, our two ratios are equivalent.